Hello guys, welcome to Code Extreme. So today we are going to do a very good question, that is LeetCode number 1539, Kth Missing Positive Integer. So given an array of positive integers which are sorted in increasing order, okay, and an integer k. So what we have to return? We have to return the kth positive integer that is missing from this array. So this array will contain positive integer starting from 1, okay, starting from 1 to 1 to we can't say, okay, because there can be elements not up to this 11, there can be elements up to 12, 13 and so on, like this is written here. So what I'm trying to say is the elements will start from 1, okay. Now we have to return the missing elements. So in this, the missing in this array, what we can see, the missing positive integers are these. 1 is missing, okay, 5 is missing, 6 is missing, 8 is missing, 9 is missing, 10 is missing, and it is also including 12 and 13, which are not in this array, but it is considering them as missing. And also it is written as so on, means that we can't say what is the length of the array actually, okay. So the fifth missing element, k's value is 5, so fifth missing element 1 2 3 4 5, so 9 is the element which is missing from this array. It is the fifth missing element, so the result is 9. So how can we do this? We can simply do this by a approach, okay. So what is the approach? Okay, so what we will be doing is we can make a variable x equal to 1, which will start from 1, as we know that the elements in the array should be starting from 1, okay. So we will compare, first we will iterate in our array. So for example, I am iterating with I, and I is currently indicating this 0th index. So x is equal to 1. So is x equal to ARR of I? No, it is not equal to ARR of I. So we can say that one element is missing. Element we have found that is missing. So what we can do is we can decrement the k, as we now we have to find only the 4 remaining missing elements, as one element we have found, okay. So now we will increment our k, okay, but we will not increment this I in this, as we have found a missing element, so we will not increment this. If we found a element that is not missing, then we will increment, like this. See, x is equal to 2 and x is equal to nums of I in this case. So what we will be doing is, we did not found any missing element here, so x plus plus, but nums I also plus plus. I hope you are understanding what I'm trying to say. So I plus plus also. Now x is equal to nums of I. Yes, again. So increment x as well as increment this uh, nums of I. So now again 4 is equal to nums of I, so 5, and here also it will indicate here 7, okay. Now 7 is equals to 5. No, 7 is not equal to 5, means that we have found a missing element, and that is 5, okay. So we will decrement our k. Now we have to find only 3 elements which are not in this array. So now the next element is 6. Is it present? No, not present. It is not equal to the nums of I. So what we will be doing is decrement the k again. Now we have to find only 2 elements, and the next element is 7. So is 7 present in our array? Yes. Nums of I is equal to x. So 7 is present. So what we will be doing in this case, we will increment the I as well as x. Okay, so now nums of I is here. Now 8. Is 8 present in our is 8 is equals to my nums of I? No, not. So 9. Is it so also k decrement also. Now we have to find only one element which is missing. So see carefully. 9 is present? No, not present. 9 is not present, means that it is also a missing element. Now k becomes 0, and whenever my k becomes 0, the element which is missing at that point is the kth missing element. Okay, so that's why the answer here is 9. So hope you understood the approach which I have tell you. So let's try to code it up. First of all, int n equal to arr dot size. Okay, now what we will be doing is int x equal to 1. Okay, int x equal to 1, and so we will iterate, but we will set a condition that while k not equal to 0. See, I forgot to tell one condition, that in this ARR there are all elements. If we see, there are all elements which are present. So how can we return the kth missing element? So we can see that these are considering that the elements of the array are not till 4. They are considering 5 also, 6 also, 7 also, 8 also, 9 also, and so on, as we saw here. Okay, so second missing element is 6 here. So we did not have to only iterate until the size of the ARR. We have to see furthermore. Okay, in some cases. So the condition will be while k not equal to 0. If k becomes 0, then we will break the loop. So it will break automatically. Now if nums of I, so we have to make I also int I equal to 0. Now if nums of if arr of I is equals to my x, what does this mean? This means we have found the element which is not missing. So in this case, I plus plus as well as x plus plus. Okay, fine. And if we did not found element, then what we will be doing is x plus plus as well as k minus minus. So k minus minus and x plus plus, and we will remove this x from here, as it is coming in the both if and else. Fine, so this is the condition. So if arr of I is equals to x, means that for what we have written this condition, if element is found, else k minus minus means that element is not found, and at last we will return the element x, which came at the point when x becomes 0, sorry, k becomes 0. So let's run the code. But there is a mistake in this. You will see, there's a runtime error. What is the runtime error? See, in this case 1 2 3 4, my k, see, x equal to 1. First of all, x is equals to 1. Okay, now my I will be indicating at first this 1. Okay, try to do this. Okay, so first I will, now arr of I will be 1. Okay, arr of I will be 1. So x is equals to arr of I. Okay, so increment both x also as well as I also. So 2 equal to 2, so increment both again, it becomes 3, and 3 is also present, so increment both again 4, and 4 is also present, so increment again, so it becomes 5. I has came to an end, arr is over, array is over, our array is over, but we are still trying to access this, that's why it is coming the overflow error. Fine. So how can we fix this error? We can simply write while I is less than n, simply check up to that, else do k minus minus. 5 will be not present. If the error is over, then 5 cannot be present. So simply k minus minus. Then 6 cannot be present. Simply k minus minus. And k becomes 0 at this point, and answer came. I hope you understood what I'm trying to say. Let's run the code now and see that error comes or not. Okay, and extra x plus plus is happening here, if you can see. When we got k equal to 0, then k equal to 0, then x might has some value. X might has some value, that is, let's say it was 6. Okay, it was 6 at this point. at this point, or sorry, at not this point, at this point, when the k decremented at the last and becomes 0. ठीक है, but x plus plus in x incremented here one time. So what we can do here, simply we can write if k not equal to 0, then do this only, else did not, else don't do this. Okay, so now let's try to run the code. I hope now this will be okay. See, it's okay. So let's submit the code. So this is the this was an approach which run in the order of n time, you can see. So it seems that the time complexity is order of n, but it is not. It is order of n plus k. Why is it so? Because in this case we iterated till order of n, then also we iterated till this k. We iterated till this k. That's why the overall time complexity of this code is order of n plus k. So can we optimize from here? Yes, we can optimize. So let's see one observation. Observation is that, can we know at each index that how many elements are missing? For example, in this, what the original array, let's write the original array: 1, 2, 3, 4 and 5. So this is the original array, but elements are missing and it becomes like this. Okay, so what we can do, we can simply check what is the value which should be here. It was 1, but the value which is here is 2. So we can we know about it that the element which is missing here is 1. How? 2 minus 1. What is 2 minus 1? It is 1. So one element is missing here. Okay, let's move forward. In this, there should be 2. There should be 2, but what is present? 3 is present. So what is the difference? Difference is 1, means that one element is missing up to this index. Okay, let's move forward. At this index also, 4 minus 3 is 1, means that one element is missing up to this index also. Now for this index 7, there 7 is present here. What should be present? 4 should be present. So how many elements are missing up to this? That is 7 minus 4. So 3 elements are missing up to this index. Okay, so like this we can figure out how many elements are present and how many elements are not present up to this index. Okay, up to any index. So if we see, we can do this by a thing that is called as binary search. How? Array is sorted. Okay, array is sorted, and also we can figure out how many elements are not present up to one index. For example, in binary search, what we do, we have 3 indexes: low, mid and high. So first of all, let us assume that mid is here. Okay, mid is here. Mid is pointing to this index, second index. Okay, so in this index, what should be the actual value? The actual value should be I plus 1. The I is 0, 1, 2, 2 and I plus 1, 3. 3 should be the actual value. We can figure out this easily. So 3 is the actual value. So how many elements are missing? So 4 minus 3, 4 minus 3, 4 minus 3 elements are missing, that is 1. So one element is missing up to the index mid. So we have to find the 5th element which is missing in this array, but we found that up to this index only one element is missing. So what should we do here? We should low equal to mid plus 1. We should place the low in on mid plus 1. Okay, so what we will be doing here, we will place our low here, high here, and mid. Where will be the mid? Mid will be here. Now what will be the next thing? Calculating for this 7. So for this index 7, what should be the actual value which should be here? That is I plus 1. So what is the index? 0, 1, 2, 3, third index. So 3 plus 1 is 4. So the value that should be present here is 4. So now how many elements are missing? 7 minus 4. So that will be equal to 3. So we can see that 3 elements are missing up to this index, but we have to figure out the fifth missing element. So again what we will be doing is low equal to mid plus 1. Okay, so what we will be doing is low equal to mid plus 1. And where will the low go? Low will go here where high is present, and mid also will be present here. Okay, so now what is the value of mid? 11. Nums of mid is 11, or ARR of mid is 11. So what should be the actual value? I plus 1. So 0, 1, 2, 3, 4. So 4 plus 1 is 5. So 5 should be here. That is the actual value. But instead of that, 11 is present here. So how many elements are missing? 11 minus 5. 0, 1, 2, 3, 4. 11 minus 5. So that is, what is 11 minus 5? 6. So we can see that up to this index 6 elements are missing. Up to this index 6 elements are missing. So what we can do in this situation, the elements which are missing are exceeded the value of k. In this case we will do a high equal to mid minus 1. So high equal to mid minus 1. Okay, if it is equal, if it is greater, then what we will be doing is high equal to mid minus 1. So high will be here. Now the binary search loop will break. Why is it so? Because binary search is a condition that while low is less than equal to high. So in this case the loop will break. But we will found this index at the end of the day, that is 7. The value at this index is 7, and we know that at this index how many elements were not present. That is 7 minus 0, 1, 2, 3, 3 plus 1, 4. So 4 should be the actual value. So 7 minus 4, that is equal to 3. So 3 elements are missing here, and we have checked after this that in this 11 and all, we will not find our answer. So what we will be doing, 7 plus k simply, sorry, it's not 7 plus k, 3 plus k. So 3 elements are missing here, so 3 plus k. So we know that 7 is present here. Okay, 7 is present here, and the actual value, see, 7 is present here. We found this index 7. 7 is present here, that is high. High is indicating this 7. Our high will be indicating this 7. Now we know that 3 elements are missing before this 7. So 3 elements are missing before this 7, but we want fifth kth value. So we want the fifth missing positive number. So what we will be doing is 7 plus k minus these three, that is the missing numbers up to this index. So k minus 3. So what will be the answer? 7 plus 5 minus 3. So 7 plus 5 is 12, and 12 minus 3 is 9. So we will get our answer, that is 9. So pretty simple. So let's try to code it up now. Int n equal to arr dot size. Int n equal to arr dot size. Now we will make the 3 variables, which is low equal to low will be at 0, and high will be at n minus 1. Oh shit, I didn't define n. Int n equal to arr dot size, and one integer for the missing elements. So missing elements, we will store the count of the missing elements up to that index in this variable. Okay, now while my low is less than equal to high, what will I calculate at first? I will calculate the mid. So mid equal to high minus low, sorry, low plus high minus low upon 2. Now if now I have to calculate the missing elements. So missing elements will be equal to, for example, our mid is here at this index. So how many elements are missing up to this index? That is 4 minus I plus 1, or we can say mid plus 1. So mid plus 1. So what is the value of mid? That is 2. So 4 minus 2 plus 1, 4 minus 3, that is 1. So the number of missing elements present at this index are ARR of mid minus mid plus 1. Okay, so these are the number of missing elements up to the mid. Now, if the missing elements are uh, if the missing elements are less than our k, then what we will be doing is low equal to mid plus 1, and in the else part what we will be doing is high equal to mid minus 1. Simple. High equal to mid minus 1, and at the end of the day what we will get our high. We saw that our high was present here at the last and low was present at the last here. So this was the breaking condition of the while loop, as low becomes greater than high. So we got this index as 7. So what was the answer at this index? The answer was 7 minus. So what was the actual value for this index? That will be stored in this missing elements. But no, it will be not be stored. This will store the missing elements will store the this for the load index where low is present, as the loop will break from after that. So we have to calculate here. So return nums of high minus. So what should be the actual value? That is high plus 1. High plus 1 should be the actual value here. That is 7 0 1 2 3, that is 4. So 7 minus 4 is 3. Okay, so 3 is the value that should be present, but it is not present. So this is 7 minus h plus 1, means that nums of high minus h plus 1. What is this? This is the number of the missing elements up to this index. Okay, missing elements up to this index. So what we will be doing is that is 3. Okay, the result is 3. So 7 minus. So we knew that 3 elements are missing up to this index, but we want 5. We want 5. So okay, so this nums of high minus h plus 1 is the count of the missing elements, and there are 3 elements which are missing at this index, but we want 5. So how many are left? How many missing elements are left? There are left 5 minus 3, that is 2 missing elements are left, or which we will get after this 7. So what we will be doing? We will simply decrement this. Now what is this? This is the k 5 minus 3. So 5 minus 3 is 2, means that 2 elements are left which are missing. So we will add them with the ARR. So ARR plus k minus this. Okay, so at here we will put a bracket, and in this also we will put a bracket, and in this whole we will put a bracket, and now it is ready to be run. Okay, now it is looking fine. Let's run the code at first and see if it is correct or not. So h plus 1, oh sorry, it was high, not h, so h. Now hope it will be running. Runtime error. So this is a condition which will prevent the overflow. Now let's run the code. I hope it will accept this code. Wrong answer. Okay, so there should be a bracket here. Now let's run the code. This time I hope it will accept the answer. Yes, it is accepting. If you understood, the time complexity is order of logn of this code. Okay, so if you understood, then don't forget to like and subscribe.